So today we would like to learn about basic rail technologies or principles for students and for engineers who are not conversant with railway construction. So I worked for the Mwanza-Isaka standard gauge railway, and also I've taught railway engineering. So I would like to give you the basics, but I'm not going to teach everything. But I think as young civil engineers, you have a lot to read. An engineer should be able to read a lot in whatever situation where he is in order to learn, and also can learn from experienced people on railway construction. So let us start with the railway gauge. So the gauge of the rail is the distance from face to the face of the rail. So there are different types of railway gauges. In Tanzania we have got meter gauge railway, and now we are constructing standard gauge railway, but also we have got what we call narrow gauge railway. So these are the common types of gauges, railway gauge. But I think there are more than 10 gauges of railways which are used in different countries of the world. So there is the narrow gauge railway, which can be 760 millimeters or 600 millimeters. And these are used in farms. For example, in sugar cane farms, in wheat farms, and different types of farms to carry, the harvest from one place to another. I have seen even in Jamaica, I saw that they are not using railway, but they are using cables to carry the banana from one place to another. So we as Africans, we need to change our mindset. We don't have to carry the banana like this one going to the market. We need to use cables now, isn't it? Okay, there is standard gauge railway. The distance between the face of the rail to another is 1435 millimeters. And that is what we are constructing now from Dar es Salaam to Mwanza and from Tabora to Kigoma. So, and then we have got a broad gauge railway, which we have got a distance of 1676 millimeters, a distance between one face of the rail to another. The design for speeds for trains varies significantly. They vary from 80 kilometers per hour up to 350 kilometers per hour, depending on the country and on the design and on the financing. But even the 350 millimeters I've written, I'm not sure. Maybe in a country like China, maybe they've got 400 millimeters or 500 kilometers per hour. So just imagine you have that type of rail in your country. So the design speed refers to the speed for which the rail line and the rolling stock are designed. Rolling stock are the vehicles of the rail moving along the rail, like the rail itself, maybe the construction rails, trains which are used in the construction, but even the locomotives carrying sugar cane and whatever, those are called the rolling stock. The curve characteristics. A constant radius R along the circular portion of the curve. We have two transition curves, one on each side and end of the curve. But what I'd like to tell you is that reverse curves are highly discouraged in railway engineering. You know, if a train is moving this direction, then it comes this direction, it can cause some accidents, what we call derailment. So those are the parts of a careful railway. You can see it is similar with the road, isn't it? Yes. We have got the tangent spiral here. Tangent spiral, we've got spiral circular, we have circular spiral, we have spiral tangent. And we've got some spirals on the two sides and the circular curve on the other side. They are not different, so it will not be difficult for you to learn. So I've said that the reverse case should be avoided when you are constructing a railway. There is what we call super elevation, but normally in railway engineering we call it cant. We can call it cant or super elevation. Super elevation or cant is the extent to which the outer rail on the curve is raised over the inner rail and along the circular curve. It is required along the curve to counteract or balance the effect of lateral forces on the train due to its movement along a circular curve. If super elevation is not provided, the lateral forces are not balanced and causes discomfort to the passengers, besides resulting in an equal load on the inner and outer rails. So you can see here you can see this, what we call it, lateral acceleration is taken 0.3 meter per second cube. So it's the same as the lateral acceleration in roads. Ruling gradient. Ruling gradient, as I said, the gradient for the rails should not be more than 2%. But in most cases, they limit it to 1.5%. That is the difference between railway and roads in vertical alignment. So, connecting for rails. You know, the rails come as pieces, and these pieces are connected together. So there are two types of connection. There are the old type of rails, where you have got pieces of about 20 meters apart, and these apart, they are connected with a piece of rail called or piece of plate called fish plate. But there is what we call continuous welded rail. You have got pieces of 400 meters connected by welding, continuous welded rails. So these continuous welded rails are used for high-speed rails, like what we are doing in standard gauge railway. So you can see the difference between this Tazara rail and the SGR is this Tazara rail. We have got pieces of about 20 meters connected with fish plates. But in SGR rail, we have got what they call continuous welded rails. So we've got very long rails connected by welding. Of course, that weld is done automatically using machine. So that is the normal rail. You can see the fish plate there. I don't know if you can see if I try to show it here. Pieces of a plate which is connected with rails. And normally you can see it's connected with boats. Normally the boats are fixed. One boat is directed in this direction. The other boat is directed in the opposite direction. So that when there is derailment, say a train fails, I mean that plate will not be removed, and then you will have a serious accident. So they use what we call fish plates. So you can see here, that is a rail, but it's connected with, expansion joint. After the 20 meter plates, they put expansion joints, as you can see there. So you can see the fish plate. Can you see it? If I indicate, is it showing here? Can you see? Yeah, those are this type of joint, they call it fish plate. And you can see there is expansion joint. There is a gap there. So in order to counteract the effect of expansion. Most modern rails are continuous welded rail, sometimes referred to as ribbon rails or seamless rails. In this form of track, the rails are welded together by utilizing flash butt welding to form one continuous rail that may be several kilometers long. So that is this continuous welded rail. I think I will not explain much. I'll leave you with, these slides, so if you want to read further, you can read it. Now, we are talking about sleepers. Sleepers are the members generally laid transfers to the rails on which the rails are supported. Rail is fixed to sleepers to transfer the load from rails to the ballast and subgrade below. Functions of sleepers are to hold the rail to the correct gauge. So sleepers are the cross members holding the rail together. So sleepers continue to hold the rail in proper position and level, to act as an elastic medium between the ballast and the rails, to absorb the blows, vibrations of moving loads, to distribute the load from the rails to a ballast. Sleepers also add to the longitudinal lateral stability of the permanent track on the whole. So classification of sleepers: we have got wooden sleepers, we have got metal sleepers, cast iron sleepers, steel sleepers, concrete sleepers, reinforced concrete sleepers, or pre-stressed concrete. In the case of standard gauge railway, we are using pre-stressed concrete sleepers, and they've got the factories which they have established in order to make the sleepers. So spacing of sleepers, they say, should be about 60 to 70 centimeters. So have you understood what is the sleepers? Have you seen it? Yes. The cross members. So now we have got the electric rails with catenaries. So electric rails can be fixed with catenaries. These are a catenary system is a network of overhead wires used to supply electric power to trains. This system consists of a series of wires suspended above the railway tracks, which trains connect to via what they call pantography. Pantographs, they transfer the electricity from the catenary system to the train, allowing them to draw the necessary electricity for propulsion. A catenary system is a network of overhead wires used to support electric power to trains. This system consists of a series of wires suspended above the railway tracks, which trains connect to via pantographs, allowing them to draw the necessary electricity for propulsion. Then there is what we call sidings. In railway terminology, a siding is a track that branches off the main line, allowing trains to pass each other or to be stored. It is a short section of tracks used for shunting, loading, and unloading freight. Sidings can be used to temporarily store trains or carriages, and they are crucial to the efficient railway operations, especially in areas with high traffic. So, for example, the Mwanza-Isaka rail, the main rail is more than 300 kilometers, but we've got catenaries of 92 kilometers. No, not catenary, sidings, sorry. The sidings. So you can imagine the importance of the catenaries. So shunting. Shunting is push or pull a train on the part of the train from the main line to siding or from one line of rails to another. Shunting, for example, if a train arrives in a certain station, it does shunting. Maybe there are some wagons which need to be removed out of the rail. Maybe they have reached their destination, so they do siding to remove them. There are some maybe other wagons which need to be connected so people may board towards another direction. They do it through the sidings. Rolling stock. The term rolling stock in the rail transport industry refers to railway vehicles, including both the powered and unpowered vehicles. For example, locomotives, freight and passenger cars or coaches, and non-revenue cars. Passenger vehicles can be unpowered or self-powered, single or multiple units. So this is rolling stock. Niko naambia kwa Kiswahili alafu nikaambia neno limenipotea. Hili inaitwa rolling stock. So, but the railway system is not only, as we see, there are some small rails which carries some trains, small trains. I have seen them in Norway. In Norway, when we are moving to offices, and so we board these, trams, or they call them light railway transport system, LRT. And this normally you can find them in a road. For example, as you are constructing this, this Njiane, you can see the road. We can see we are living in the middle. We are living some 9 meters in the middle for carrying buses. But one of my lecturers asked me, why don't you use the trams? Normally the trams, you may find them even they are passing on the same places as the other vehicles, what I've seen in Norway. But of course in Tanzania we selected to use the buses. They are almost the same size, as you can see. And the rail is passing on a bituminous road there. And the vehicles are also passing in the same place. So these are called trams. And what I saw on the trams, I see some wires, a grid of wires. So, and the bus is passing, and they've got a certain piece of wire, a certain piece of iron, which is when the light train is passing, it touches the wires and it draws the electricity. But I've also seen in Norway, they've got underground train, subway, where the trains are passing. And in that country, what I saw is that they are not using the catenaries as we are using, but they are drawing the electricity from the wheels down. And normally when they construct these type of trains in their country, they don't allow anybody to go down there because there is electricity. So it is dangerous when we are having people who are not disciplined. So this is the railway transportation in a tea farm in Sri Lanka, Ceylon, Sri Lanka. Train transportation in farms. Trains are extremely used in plantations, particularly for transporting harvested crops and materials. They facilitate efficient movement of goods from fields to processing facilities, mills or ports. Narrow gauge railways were commonly used in plantations, allowing for easy access to interior areas and the efficient transport of materials like fertilizers and harvested crops. So you can see these types of train. We saw them in sisal farm in Tanzania and also in sugarcane farm. For example, I think if you go to TPC, who are going to TPC, Tanzania Plantation Corporation, in Moshi, they are manufacturing sugar, and they use this type of transportation to transport the sugar cane to the factory. Use of rails in towns. Much of the wheat needed to feed these mills can come from Bonanza Farm. Oh, this is not very important, but rails are used in towns. So, ladies and gentlemen, I think I've given you the basics for railway engineering. But railway engineering is very wide, and this is just an introduction. But as a civil engineer, you need to be able to read a lot, because even myself, when I was given the assignment to be the civil engineer for Mwanza Isaka, I had to read to know what is actually happening. So don't be afraid. And I think we can continue with discussions, and I think we can discuss in Swahili. Thank you very much for listening to me.